Greg, it's so great to have you here this morning. Thanks for taking some time to talk to us about the work that you and your sequencing core have been doing to try to understand sequence variants and novel variants of the SARS-CoV-2 virus. So Greg, can you just tell us a little bit about the work that you've been doing? And by the way, I remind everybody that Greg gave a fantastic talk for our COVID seminar series, which is also available on our website. So Greg, yeah, I'd love to hear more about the work that you've been doing at Duke sequencing the SARS-CoV-2 virus.
Great. Yeah, no, thank you, Swati, and I'm happy to be here to chat with you. Yeah, when the pandemic really started to get going about a year ago, a little over a year ago, we realized that there would be a need from investigators at Duke to understand the nature of the virus itself as well as host responses. And so we began to develop the ability to look at those using molecular assays within the core facility. And we've now been working with a number of investigators as well as the surveillance efforts on campus now for almost a year.
That's great. And can you talk a little bit more about the scope of what you've been doing? You know, how many people have you been able to sequence, and what have you learned from the work that you have been doing?
Well, at this point, we've sequenced about 2,000 genomes from about 2,000 individual samples. In most cases, this is a virus where you've really only got one strain. So number of people we've sequenced is around the same number as the viral genomes we've sequenced. Many of these end up being almost identical because they were transferred on campus or near campus within the community. But we also have some highly divergent ones that have probably come into the community by people traveling and getting them from outside the campus or Durham communities. And what we've learned from this is that, as has been seen elsewhere in the world, the strains that are circulating actively are really changing over time quite a bit, and in some cases quite dramatically.
And how does this inform how we think about the current pandemic and, unfortunately, future potential pandemics, because it's likely that, you know, this is not the last one we see? And you had some really great insight in that sense of what we, you know, looking back, what we could have done better at Duke and even nationally with regards to that.
Yeah, I think, you know, we've all been trying to figure this out in real time. So I don't want to be an armchair, critic, but I think any population geneticist, epidemiologist, evolutionary biologist would have told you a year ago the virus is going to change and adapt. It will adapt to be faster transmitting, to be able to evade induced immunity, to be able to evade therapies. Unfortunately, we don't have a lot of those, but as they come online, we can expect that to happen as well. And so what we want to be able to do is monitor how the genetic makeup of the virus populations that are circulating, how that's changing, and what we would then need to do to up our game, because it is to some extent a bit of an arms race. And this will certainly be true in any future pandemics that come along. So to your point, I think we do want to learn some lessons here about what we could do maybe to get mobilized a bit faster with some of these surveillance efforts, and as a global community to coordinate on what we're learning. That has happened, but it took time because, again, people were building these interactions essentially in real time. But the good news is this is the most thoroughly monitored pandemic in history. I mean, it's not good that it's a pandemic, but it's good that we've been able to kind of put in place some of the procedures and connections between health systems in different countries so that we truly have an almost real-time global perspective on how this pandemic has unfolded.
Yeah, great answer. Digging into the actual biology a little bit, you presented some interesting data about specific variants, and that certainly helps in epidemiologic monitoring of, source infections, community spread. My understanding is that this could also help us with potential therapeutics and development of new therapeutics. So can you talk a little bit about that? And then as a follow-up question, how do you figure out if a given variant is actually pathogenic? Because maybe you don't want to target something with a therapeutic that isn't pathogenic.
Yeah, no, these are great questions, and they're related. I think, we're really at the kind of dawn of being able to relate how genetic changes in the pathogen are affecting things like transmissibility, whether it's more virulent, the fact that some of these strains are spreading quickly, could happen in a variety of ways. And we really, at this point, it's observation that some of them seem to be spreading faster. It's not the case that we know exactly why. There's certainly some good ideas, and there's certainly some supporting evidence. For instance, the UK strain appears to render at least some people producing virus for a longer period of time. So they come out of quarantine and they're still shedding virus. Knowing that's been really, really important in terms of managing from a public health perspective. But that still is, we're still a long way from understanding from the virus's perspective, what is it about its genetic changes that give it that property? And in terms of therapy, wow, we're really at the dawn of those efforts. But all of that is going to be built on our understanding of how this pandemic has unfolded in terms of the genetic changes in the virus.
Yeah, I think that last statement is so important, and the work that you've done really highlights that. I'm curious what you think about this double mutant that everybody seems to be worried about. Can you put that into context for us?
Sure. Yeah. So the double mutant in India, I mean, India's unfortunately facing really an almost catastrophic increase in cases, and the health system is really at the breaking point. Just from a personal perspective, one of my high school friends is a doctor in India, and I just found out last night that she has COVID, and she's doing okay, but her hospital is really at the breaking point, and so this has been a real tragedy. Now, the double mutant, all of the so-called famous strains like the UK strain, the South Africa strain, and this one in India have more than one mutation that distinguish them. When we speak of double mutant, I think what really what we're trying to convey with that kind of a label is that this might be two different changes. Now, some of those genetic changes may not matter at all. They're just passive passengers that are being carried along by the mutations that really cause a change in, let's say, transmissibility. But in this case, it's thought that there might be two separate mutations that are actually altering transmissibility. Again, very early days to try and really get our heads around that, but there are a lot of smart people who are trying to figure out the right statistical approaches and gather the right data to begin to really dig into that.
I'm so sorry to hear about your friend. I hope she continues to do well. I think it just, that highlights the need to have this surveillance at the sequencing level so that we can get on top of these. So maybe this double mutant isn't anything that but we have to be able to study it to be able to understand what it might do. So Greg, this was really a great conversation. Any final thoughts or what the future looks like in this space for you and for Duke? What would you like folks to know?
Well, in spite of all the challenges we faced over the past year, I do remain optimistic that this has been an amazing global community of science kumbaya moment, really, in a sense where we've really learned how to work together in ways that we wouldn't have done if there had not been this motivation. So I do think we're better prepared, and when this happens next time, we'll be better at it.
Great. Well, thank you so much for your time. This was really informative. Thanks, Greg.
Thanks. I enjoyed it. Thank you.